So this is a continuation from video one to this video, and previously we spoke about the function of y equals x minus 2 in parentheses squared, which is a parabola, and you also see a picture of it here. But anyway, this particular problem that they've given us is not a function. So where this particular one proves that they are not functions is correct here. We have a 0 and a 0, so the same x values pointing to two different y values, and that is not a function. So we're going to talk about that a little bit. We have a vertical line test down here. If you read through that, it says if you draw a vertical line through a graph and it touches the graph in more than one spot, it is not considered a function. It would mean that there's at least one x value that has two y values, so therefore it is not a function. But this video that I have will illustrate that, and then we'll also show it for the equation that we had yesterday. So let's jump into that so you can see it. Here we go. Okay, so here what we have are the 4 points in the table that were graphed. And what we're going to do with those 4 points is I want to be able to finish the whole graph because the 4 points really don't indicate what this shape looks like. This shape, if you've got x squared plus y squared equals 1, is a circle. So when I actually connect it, you will see that it forms a shape. Now, we also know just from our points that we have a 0, 1 and a 0, negative 1. So by the definition of a function where each x only has one y, we know this is not a function. But another way to determine that is the vertical line test, which I talked about. If I have a function like this and I draw a vertical line, which I have plotted here, and I go back and forth through the drawing, you'll see here, it's a little green line. I'm going to go slowly through it. It hits at the 2 points, and it crosses. If I just go right through the graph, it is hitting at multiple spots where it's 2 points. So that is really important to understand. So just based on the fact that I'm right here and I have a vertical line that's green and it hits 2 points on my diagram, that is proving with the vertical line test that this is not a function. But it also makes sense with the definition that we have for a function. So that should help you a little bit with functions. The one that we did before, which was a parabola, is always a function. But then again, you can draw a vertical line on that, and it will actually be only touching in one spot. So here we go. That's it. Now that you've watched that little video, we're going to move on to the second video that I have, which actually does show the vertical line test also with the y equals x minus 2 squared, this lovely little equation right here. So we'll put that on, we'll show that video, and that'll further explain what it looks like when it actually is a function. So here we go. So here's our graph that we had from the last equation, the x minus 2 squared, which is our parabola. So I just wanted to show you the vertical line test here where it proves that this particular function is, or this particular graph is a function. So if you look, as I go through this graph, it is only hitting in one spot. And so that proves through the vertical line test that the function we were working with the other day, again, x minus 2 in parentheses squared, is a function. So hopefully that helps explain it a little bit further as well. We are now moving on to the next slide. Okay. So what we have here is linear equations. This is the next methods and meanings math notes. A linear equation is an equation that forms a line when it is graphed. This type of equation may be written in several different forms. Although these forms look different, they are equivalent, that is. Their graphs are all the same line. So on this one, we have the standard form. And so the standard form is ax plus by equals c, which you see as an example here is the negative 6x plus 3y equals negative 18. Now, they've been really good about telling us that these two particular equations are equivalent. So the y equals 2x minus 6. But I'm going to show it to you algebraically, and then I'm going to show it to you graphically through this little video. So let me go ahead and start. I've got negative 6x plus 3y equals negative 18. I want to get it into slope-intercept form, which means that the y will stay on the left side of the equation. So the first thing I'm going to do is add 6x. So that's going to leave me with 3y equals 6x minus 18. Then, if you remember algebraically, we're now going to divide by 3. So that's going to leave y equals 2x minus 6, which is equivalent to the slope-intercept form. So it's important to know that you can have two different forms that look different but are equivalent. So now what I'd like to do is take a moment and let you watch this little video that explains it even further for the comparison between the two forms. Okay, so on this particular slide, I wanted to be able to show you through Desmos that the two equations that they've given you here in standard form and slope-intercept form are equivalent. So I'm going to start by now this, you cannot enter equations in the same way on your Texas Instrument calculator, which is what a lot of classrooms use. But on Desmos, you can look at this and you can compare it. So I'm going to type in the standard form of the equation that they gave us, which was negative 6x plus 3y. You'll see that things are swapping around as I type, equals negative 18. Okay, so there you've got your graph in black. And now what I'm going to do is I'm going to add another one, and it'll be a different color, but it's going to be the slope-intercept form of this particular equation. So they gave us y equals 2x minus 6. And as you notice, it's taken the red line and put it right over the black line. So they are equivalent equations, just algebraically written differently. So if I go ahead and get rid of the red for now, just so you can see the black, and then I hit this so you can see it graph again, that shows you they're equivalent. And that just helps you realize that you can write equations and manipulate them in different forms in order to graph them or work with them for different reasons. So here we go. So now what I would like to do is show you the vertical line test for this particular function as well. So it kind of reinforces the knowledge that you have from the function information and vertical lines. So here we go on that video. So this is just a short, quick video to go along with this methods and meanings math note about linear equations. I spoke briefly previously in this video about the vertical line test, how you can show that a graph is a function. Well, this is a function, and I'll show you first with the vertical line, and then we'll talk a little bit about the points. So if you notice here, I'm using the same green line that's going across the graph, and it only hits that line at one spot at a time. And so it means that every x value has only one y value. So this ends the videos for the combined methods and meanings note sheets, one on functions and the other on linear equations. I will be jumping into parent resource examples right now for chapter 1. So we'll see you on the next video.